Hello students, in this video we are going to understand the concept of the difference equation. Basically we are going to solve the difference equation. There are two methods by which we can solve any difference equation. One is a direct method, another is indirect method. The indirect method is basically associated with Z transform. Basically it is based on Z transform. So in the second unit we will be going to study Z transform. So that we will discuss in the upcoming videos. Right now we are going to concentrate on direct method. So basically in the direct method the solution consists of two parts. First is the complementary solution, another is the particular solution. Complementary solution, also known as zero input response, can be denoted by YHN, and particular solution, also known as zero state response, can be written as YPN. So when you solve the difference equation with the help of direct method, the final complete solution can be expressed in the form of Yn which is equal to YHN plus YPN. So basically we have to consider the difference equation first, and then we will solve the difference equation in two parts. In the first part we will calculate the complementary solution, and in the second part we will calculate the particular solution, and then we will add both the parts. That will be your final solution of any difference equation. So first we will see how you can calculate YHN. So to find YHN, what we need to do is the given difference equation, we have to replace Yn with r to the power n. So the equation now will become in the part of r to the power something. So it will be an equation which can be solved, and we can solve its roots. So there are two possibilities of roots. So both the case I have considered. First case is roots are distinct. That means suppose you have solved any equation and you find out the roots and they are different roots. So then the solution YHN is equals to C1 lambda 1 to the power n plus C2 lambda 2 to the power n plus C3 lambda 3 to the power n, and so on. Case 2, multiple roots. That means if suppose two roots are same, then YHN is equal to C1 lambda 1 to the power n plus C2 n lambda 1 to the power n. That means suppose two roots are same, so then the equation will be written in the form of C1 lambda 1 to the power n plus C2 into n. That means you have to multiply the second with n. Obviously C1, C2, C3 are constants. So this way we can find the various roots. Okay, so this is what the first part of your difference equation solution, which is complementary solution. In the second part we have to calculate, or we have to find the particular solution. So to find particular solution, there is an important rule. If any term in the particular solution is present in the complementary solution, that means first you have calculated the complementary solution and now the particular solution is same as the result which we find out in YHN. That means both are same. So in such case we have to multiply Yp by n. The same case of multiple roots where we have multiplied with n, here also we have to multiply the particular solution by n if any term is present in the solution, or you can say the same as particular solution. If such term appears r times, then multiply by n to the power r. Suppose the term is coming twice, so that means you have to multiply it with n square. So some common inputs and their particular solution. If the given input is any constant a, that means the particular solution would be k. If input is the unit step function, then the particular solution would be k un. If it is a c to the power n, that means the input is in the form of something like this, a c to the power n, then the particular solution would be k c to the power n. And finally, if it is sine or cosine signal, that is if input is in the form of a cos omega naught n, then the particular solution would be k1 cos omega naught n plus k2 sin omega naught n. These are the some common inputs in their particular solution. So this is how you can solve any difference equation. Now we will take a question and then we will solve that question with all the aspects. Then you will be able to understand the concept easily. So now let us consider this example. The question is yn minus 3, yn minus 1, minus 4, yn minus 2 is equals to x of n, where x of n is equal to 2 raised to the power n for n is greater than or equal to 0. Here, in some questions, the initial conditions will also be given in the exam, like y of minus 1, y of minus 2, these values will be given to you in the exam. If they are not given, then we will consider these initial conditions as 0. So, in this question it is not given, so we will consider the initial condition as 0. So first, in this question we will find the complementary function CF. So what is the rule? We need to convert yn with r to the power n, and xn is equals to 0, because this is 0 input response, so the input we have to consider as 0. So this equation will become r to the power n minus 3 r to the power n minus 1 minus 4 r to the power n minus 2 is equals to 0, as xn is 0 and we have converted yn with r to the power n. So this equation will be like this. Now from this equation we keep out r to the power n minus 2, so this will become r square minus 3r minus 4 is equals to 0. So this equation can be solved by r square minus 4r plus r minus 4 is equals to 0, and so on. So this way we can solve this quadratic equation and find the roots, which are r1 is equal to 4 and r2 is equals to minus 1. So we have got two roots and both the roots are distinct. So our complementary solution is c1 4 to the power n, that is c1 first root to the power n plus c2 second root to the power n, which is minus 1 to the power n. So this is the complementary function. Now we will calculate the particular solution. So as particular solution, as xn is equals to 2 raised to the power n, that means ypn is equals to k 2 to the power n, as per the table which we have just now discussed. So now we will replace this equation completely. Yn will be k 2 to the power n, 3yn minus 1 will become 3 k 2 to the power n minus 1, and minus 4 k to the power 2 n minus 2, and is equals to xn, which is 2 to the power n. So from this equation, keep 2 to the power n out, it will become k, it will become minus 3k, and this will remaining 2 to the power minus 1, which is 1 by 2, and then minus 4k 2 to the power minus 2, which is 1 by 4. This 4 and 4 will get cancelled, k and k will get cancelled, this 2 to the power n will get cancelled. So the remaining thing is minus 3k by 2 is equals to 1, which is k is equals to minus 2 by 3. So our yp of n, that is the particular solution, is minus 2 by 3, 2 to the power n is the final solution. So our complete solution is complementary function plus the particular solution, which is yn is equal to c1 4 to the power n plus c2 minus 1 to the power n minus 2 by 3, 2 to the power n. Now c1 and c2, these two are constants which are not known to us. We need to calculate the values of c1 and c2. So now to calculate c1 and c2, we need initial conditions, just now we have discussed. So if it is not given, let us consider y of minus 1, y of minus 2 is equals to 0. So now in this equation, put n is equals to minus 1. So what this equation will become? It will become y of minus 1, c1 4 to the power minus 1, plus c2 minus 1 to the power minus 1 minus 2 by 3 2 to the power minus 1. I have replaced all the n with minus 1. So this equation will become y of minus 1 is 0. This will become c1 by 4. This will become minus c2, and this will be minus 2 by 3 into 1 by 2. 2 get cancelled, so this is 1 by 3. So this equation can be written as c1 by 4 minus c2 is equal to 1 by 3. This will be our equation number 1. Now similarly, in this equation, now replace n by minus 2. So this equation will become y of minus 2 is equals to c1 4 to the power minus 2 plus c2 minus 1 to the power minus 2 minus 2 by 3 2 to the power minus 2. So 0 c1 by 16 minus c2 minus 2 by 3 into 1 by 4, which will be c1 by 16 minus c2 is equals to 1 by 6. This will be equation number 2. So by solving equation number 1 and 2, we will get C1 is equal to 8 by 9 and C2 is equal to minus 1 by 9. So our final solution will be yn is equal to 8 by 9, 1 by 4 to the power n, minus 1 by 9, minus 1 to the power n, minus 2 by 3, 2 to the power n. This is how you can solve the question given to you. Now in place of xn, there can be anything. It may be un, it may be cos omega naught n or anything. So according to that, we can change the particular solution thing and can solve the questions accordingly. So I hope you understand the concept of difference equation. In future, I may give you more questions on this topic to better understanding. As far as in this video is concerned, I hope difference equation concept is clear to you. If you have any doubt, please write it in the comment section. Thank you.